Never be afraid. There's nothing which is known which can't be understood. And there's nothing which is understood which can't be explained. For over 50 episodes now, my team and I have brought you to the very frontier of knowledge in physics and astronomy. And still, our mission goes on. To present you with your birthright, an understanding of the universe. I've traveled the world seeking out a certain type of genius. Masters of not only their academic disciplines, but also at explaining their research in understandable ways. And I've bestowed upon these women and men the title of Titanium Physicist. You're listening to the Titanium Physicist podcast, and I'm Ben Tippett. And now, allez, physique! Oh, Mars, we're fascinated by it. It fascinates us. It grabs and holds our attention. And like a teenage crush or like a really good piece of music, our curiosity is driven by our formless obsession with it rather than the other way around. Even if we didn't know anything about it, I'm pretty sure we'd still love it. And the more we know about it, the more we want to know. It fascinates us. I'm having trouble articulating the heart of our fascination for Mars in a way that doesn't depend on my culture. I'm Canadian, and my ancestors were immigrants here. They were the type of people who left their familiar landscapes behind and grew roots in new places. And my culture is a settler culture who embraces and romanticizes the idea of abandoning history for the sake of adventure and exploration. So I would probably describe our obsession with Mars in terms of conquest. I imagine Mars as an empty world, a blank slate. I imagine space travel. I imagine settlements. And I'm not the only one. The Mars One organization, whose desire is to aggressively settle the red planet, had thousands of people volunteer to make the one-way trip to live and die on Mars. But as I said, I'm not sure that this Mars is an empty world paradigm isn't just my settler culture talking. I think the heart of our fascination is deeper than that. I'm no anthropologist, but I'm willing to bet that every human culture whose homeland sky isn't permanently overcast has a name for it and has stories about it. Even before we knew what it was, it stood out. It travels through the sky on a weird path. I mean, the word planet has roots in the Greek word for wanderer because the planets were recognized as these weird stars who wandered around the sky instead of belonging to a constellation. Also, it's red and bright and weird, and it's noticeable. So even before modern times, we recognized it as special. Heck, even the Romans named it after their favorite god. Now, Galileo was the first human to recognize that it was a sphere, huge and distant, reflecting light from the sun with phases just like the moon. And from that point on, the more we knew about it, the more we wanted to imagine visiting it. I'm not sure how many books, movies, television shows, and games and songs have been written about what it would be like to visit, settle, invade, or get invaded by Mars. Somewhere between half of them and all of them, I'm pretty sure. The public's thirst for hearing descriptions of what life on Mars would be like, it's got to be driven by more than just a desire for a new place to live. It's raw, unrefined curiosity. And curiosity this deep is never about anything other than ourselves, our own history, and our own origins. What if things would be different in the deepest possible way? How much does who we are depend on where we're from? And in search of a truer sense of ourselves, we imagine ourselves being raised in our neighbor's family, or in a neighboring city, or a neighboring continent, or a different time, or even on a neighboring world. And so it fits that to properly understand ourselves, we study Mars. And to properly study Mars, we need to know more about ourselves. Today on the Titanium Physicist podcast, we're talking about astrobiology, the study of life on Mars. So speaking of deep questions and speculative musings, today's guest hasn't been on the show in a while, but I'm super happy he's back. He's the author of the popular and many-faceted webcomic Saturday Morning Breakfast Cereal. Welcome back to the show, Zach Weinersmith.
Hello. Hi.
Yeah. Okay, Zach. For you, I've got some magnificent astrophysicists. Arise, Dr. Catherine Neish. Dr. Catherine did her undergraduate with me at UBC and got her PhD from the University of Arizona, and she's currently an assistant professor at the University of Western Ontario in Earth Science, where she studies planetary surfaces. Now arise, Dr. Briony Horgan.
Dun, dun, dun.
Dr. Briony did her PhD at Cornell University, and she's currently an assistant professor at Purdue University, where she studies the geology of the Moon and Mars. All right, everybody, let's talk about getting a life.
On Mars.
On Mars. Let's talk about life, Jim, but not as we know it.
Or maybe as we know it. That's the cool thing about Mars, is it might be one of the only places in the solar system with habitable environments that Earth critters could live on today. If you transplanted them from the Earth to certain places on Mars, they might be able to live, and that's what we call a habitat. So a habitat is a place where any known life on Earth could live, essentially. So Mars has a lot of things in common with the Earth. It's also a rocky planet. There's ample evidence of ice on the surface, and in some places there might actually even be liquid water. Liquid water is not stable on the surface of Mars today because the atmospheric pressure is too low, but under the surface you might find liquid water, and we do see evidence that it might be flowing out onto the surface. So we've got water, which is one of the ingredients we typically think of when we're finding habitats for life. You need organic molecules. They have the fun acronym of SNOPS, which stands for carbon, nitrogen, oxygen, hydrogen, phosphorus, and sulfur, which are the 6 main elements that life uses. There's been some question of whether or not Mars has a lot of carbon, but in general, it's not crazy to think that Mars might have these ingredients for life. And then lastly, you need energy, and Mars has energy in the form of, say, solar radiation and other forms of radiation on the surface. Maybe not so much geothermal energy like we have in abundance here on Earth, but as I said, it's not crazy to think that you might find these 3 elements of a habitable environment on Mars.
Yeah, and the other key thing about Mars, too, is that Mars is by far the most Earth-like planet in our solar system. You know, we'll talk about later about how Mars probably once had flowing rivers and maybe even oceans and lakes and all these things. And so when we look at Mars, we're studying a planet that's very similar to Earth in a lot of ways. And so that means it's the kind of place we can not only imagine life thriving, but also we know kind of where to look for it, which is pretty cool.
Yeah, so this would be life as we know it on Mars. So we look at lots of places in the solar system for life, and there might be weird life. Some people think you might find life in methane oceans near Titan's North Pole, and that's life we do not understand very well. But on Mars, what we're probably looking for is something that looks sort of like us, which makes it easier to find, because we have some idea of what life looks like on a rocky world with water, since that's us, right? We know what we look like. So you could think of finding life like us on Mars.
What sort of cues would you look for?
Like for the life itself or for where it might be?
Yeah, like is there a signal you would expect? Like life on Earth emits, chemical signals we can detect.
Yeah, so the word for that we use is called biosignatures. And so biosignatures are any sign of life, either life that exists now or life that used to exist and left a fingerprint of some kind, either chemical or physical, like in the form of a fossil, like a dinosaur bone is technically a biosignature, right? But there's all kinds of other things that life can leave behind or produce and we can find. A really great example of that is one of the first mysteries about Mars today, and that's the fact that we've actually detected methane in the Martian atmosphere. And, you hear about methane on Earth a lot. It's a really common gas. And you hear about, cows contributing to the methane as a greenhouse gas on Earth all the time. But, it's possible that there could be microbes on Mars that are producing methane today. And so we've actually detected it. It's a hard detection to make, but we've detected it both from looking at Mars from the ground back here on Earth, from the Curiosity rover on Mars, as well as from orbit on Mars. And that's significant because methane, again, it's a gas that can be produced by microbes in pretty large quantities, and it's not stable over long timescales in the atmosphere. So, it should go away over the course of a couple of thousand years. And so the fact that we see it means that it's been produced really recently. But yeah, so that's one interesting mystery about Mars.
Tiny Martian cows. That's what I always picture when we talk about methane on Mars.
Yeah.
It could be produced abiotically, though. That's there are several plausible mechanisms that you could produce this without the tiny Martian cows. There are certain reactions with rock and water that can also produce methane without needing life. But trying to tell those two apart can be very difficult.
But it means that something's happening on Mars today, so that's really exciting.
Of course, something's happening on Mars. NASA keeps throwing stuff at it.
Do you think, is there any risk that we would contaminate? I know they try to keep the rovers very clean, but do you think there's any risk that accidentally some very robust microorganism hitched a ride?
Oh, yeah.
Absolutely.
Yeah, we can't totally sterilize anything we send to Mars. And we actually haven't been really trying that hard to sterilize most things we've sent.
Really?
No, it's true, because it's really hard. I mean, you have to sterilize things. You have to put them in an oven that's like 70 C, 100 C. It's pretty hot. And so that's really bad for a lot of instruments and things. And so it's not something you do unless you have to. So no, we've definitely sent microbes to Mars. It's just, we're basically, every time we send a new spacecraft, we're colonizing Mars a little bit more.
Yeah,
so you think, like, if we came back in 100 years, would you, like, that obviously would contaminate things a little if something did survive?
We're probably okay right now because the surface of Mars is not a habitable place. The pressure is super low. It's freezing. The radiation environment is super intense. So anything that's on Mars, holed up in one of these spacecraft, they're just staying put. They're just weathering out this winter. But if conditions ever change on Mars, if the climate changes, that's when you have to get worried about introducing terrestrial life into the Martian environment. Alternatively, if we drill anywhere on Mars and get down into that layer where we might find liquid water under the surface, then you're also in trouble. You might contaminate Mars that way.
This is something that NASA worries about, though. I mean, there's a whole office at NASA that's called planetary protection. And half of that is about, protecting Earth from bringing dangerous alien microbes back to Earth to kill us all. And so that's, when we bring samples back from the moon and from asteroids, they're in charge of making sure that nothing escapes. But they also deal with trying to protect other planets from us. And so they're the ones that are in charge of saying, how sterile a rover has to be. Where are you allowed to go on Mars? There's whole areas of Mars that are called special regions that we're not allowed to land on with a rover because the rovers we're sending right now are all nuclear powered. They all have these radiothermal generators on the back. And if those crashed into a place on Mars that had subsurface ice, it could create this long-lived, warm, wet environment from that, that nuclear generator, basically. And so we're actually not allowed to send rovers anywhere near those kinds of places because of that concern.
So the places we'd most want to look for life, we can't actually go to.
Yep.
You just can't get enough energy from photovoltaics on the surface of Mars?
For life.
It's just the best way to get energy is from a small radiation source?
Oh, yeah. So the previous class of rovers, like Spirit and Opportunity, the Mars exploration rovers, they were solar powered. And they did pretty well, but the problem is the newer rovers are beasts. I mean, these are small SUV kind of sized rovers, and so they need a really powerful power source. And so that's when you go nuclear.
I see.
Yeah, actually, the Mars rovers were a bit of a surprise. They only thought they were going to last a few months on the Martian surface because it's such a dusty environment. They thought dust would settle on the solar panels and the rovers would be dead after a few months. But it turns out there's dust devils all over Mars, and they cleaned off the solar panels regularly. And so Opportunity's been going for 10 years now plus?
More than that, yeah, maybe 12.
Yeah,
it's
12 years,
driven, going at 0.025 miles per hour. Opportunity's driven more than a marathon on Mars today. So that's how long it's been.
World's slowest marathon.
The team has definitely gotten smaller that runs it, but it's still finding new things all the time. They get to new places and they get there slowly, right? And they don't have all the instruments they used to, but they're still finding cool stuff. So yeah, it's still going. And it's cheap now. It's really cheap to run. That's one of the great things about it. Now that it's been there for so long, we know how to do it really well. And so it costs so little money to find new things about Mars with this rover.
So why is it if we have a gigantic rover with all these tools, but it hasn't found life? Is that because it's just really hard to detect, or it doesn't have the right tools that we think it needs, or what?
It doesn't have the right tools. Yeah. So
really?
we haven't sent an instrument anywhere in the solar system to look for life since the 70s. Isn't that crazy? It's crazy to me. There was one spacecraft, the Viking spacecraft, which flew in the 70s. It landed in 2 places on Mars, and it actually had a suite of instruments designed to look for life. This was Carl Sagan's brainchild. But since then, we've looked for organic molecules. We've looked for, different compounds and different minerals, but nothing that actually looked for life in a systematic way like Viking did.
Do you think some of the romance left after Sagan died? It seems like to the public that's the most exciting thing.
Yeah, well, I think it's because of Viking. I think the results were really controversial and we're still trying to understand them. So I think that was part of it. They didn't conclusively find signs of life. And so I think that's put a real damper on, how do we actually do that? It's really hard.
It is a really hard thing to do, yeah.
Now's the time for the big, crazy reveal, because Zach's going to die. He's going to die.
Catherine,
I'm sorry, Zach. Write an email to your wife, because this fact is going to knock your socks off.
Yeah, so Viking had 4 different experiments to look for life, a different combination of things. And the idea was if more than one of them, saw signs of life, then you could say, we might have found life on Mars. And the really crazy thing is that 2 of them had really controversial results. And so the first one was an experiment to look for organics, just organic molecules that could either be the building blocks of life or, formed by life in the soil on Mars. And at the time, that result came back totally negative. They didn't find any at all. Since then, it turns out we've learned that Mars has this really nasty kind of salt that basically falls out of the atmosphere and lands all over the soil and gets mixed into the soil. It's called perchlorate. And it's this really nasty salt because when you heat it up to high temperatures, it oxidizes, it burns to the point where we actually mine it and use it in rocket fuel. And so the problem is on Mars, when you heat it up in your instrument where you're looking for organics, and the way you do that is you heat everything up and burn it and see if organic stuff comes off. It destroys the organics because, again, it's like heating up a rocket fuel inside your instrument. So we now know, we've actually sent this instrument to Mars twice since Viking, and now we know that this stuff is there, and we know what kind of byproducts that reaction between the organics and this perchlorate nasty salt stuff produced. And we think Viking actually found that. So even though at the time they thought they didn't find organics, we actually now think they did. And so there were at least some trace organics in the soil at the Viking site.
So the other experiment that Briony was talking about was called the labeled release experiment. So what they did is they took a tiny sample of the Martian soil, they brought it into the spacecraft, and they dumped nutrient mix. So it had all the things they thought that little Martian microbes want to eat. So let's call them radioactive bananas, because the carbon was radioactive. So then they looked at the results. They tried to see if these Martian microbes breathed out any radioactive carbon dioxide, like we might if we had a radioactive banana. Okay, so they dumped in the soil and then the nutrient solution. And what do you see? What do you think they saw?
Did someone wave?
Not quite, but they started to get this radioactive carbon dioxide coming out, which is totally consistent with the Martian microbes eating the radioactive bananas and breathing out the radioactive carbon dioxide. So, you'd think checkbox, yeah, we found life on Mars. They heated it up and they didn't see the signal, so that's a good control, because you probably would have killed any of the Martian microbes at those sorts of temperatures. But the reason we're all not, cheering, yay, there's life on Mars, is there's still some weird peculiarities with this experiment. So often what they would do is they would dump in a second batch of radioactive bananas to see if the Martians would keep eating them. But instead of seeing another spike in the carbon dioxide, it actually would drop off. So that's not entirely what you'd expect for a little Martian critter on the surface of Mars. So we still don't actually really understand these results. My guess is it's probably some weird soil chemistry we don't really understand at this point, but it's hard to definitively rule out life, honestly, based on these results.
Huh. What's weird is I feel like at my house I could get like a river water sample and I could look in it and I could see fairly small things. Is there not like an equivalent you could do on a rover?
Well, the problem is that any of the life we're looking for on Mars is true microbes. It's tiny. That's all we think is there. And it's also probably not concentrated enough that you could really go somewhere and find a lump of microbes that you could resolve. And also that the surface where we're roving around on just really isn't habitable anymore. It's again, as Catherine was saying, it's just bathed in radiation. It goes through crazy night-day temperature cycles. The atmospheric pressure is just way too low to allow liquid water. And so we don't really expect to find, colonies of microbes living on the surface where we can get to them. Now, if we could send a giant drill to Mars that could drill down, 200 meters into the subsurface, we might be able to find living microbes there. And so that's sort of a pipe dream of astrobiologists, is to send one of these huge drills to Mars someday.
But then you have to be sure you're not contaminating it with terrestrial life. I mean, we have this huge drilling program in Antarctica. There's this subsurface lake, Lake Vostok in Antarctica, but nobody wants to drill into this lake because if there's life there, they don't want to contaminate it. And we have the same problem on any other world in the solar system.
Except Russia. Russia went ahead and drilled and totally contaminated the lake.
Yeah.
They did.
Oh, no.
Yep.
But they found microbes in it, didn't they?
They did, but they don't know if it was contaminated or not.
And so we can contaminate it with drills. Contaminate it with spacecraft that have been sitting there for 50 years. We've also been throwing rocks at each other, for billions of years in the form of meteorites. We see Martian meteorites on the Earth. There could be terrestrial meteorites on Mars. So, it's called panspermia, this idea that you could transfer life throughout the solar system with these microbes hitching a ride on a meteorite.
Yeah, and there's actually one meteorite from Mars. It's a really ancient meteorite. It was from rocks that were formed over 4 billion years ago that we found in Antarctica. And every planetary scientist worth their salt knows the name of this meteorite. It's ALH 84001. And this meteorite basically sparked a revolution in astrobiology. It really created the field of astrobiology because when scientists cut open this meteorite and started looking at it with microscopes and all kinds of really advanced technology, they discovered weird mineral deposits and other weird things in there that on Earth would normally be formed by life, like, sort of bacterial poop coming up behind the bacteria and forming, little magnetite ridges and carbonate bands and things like that are on Earth would be what we consider a biosignature, and they found them in this meteorite. And so, President Clinton got on TV and says, we think we found evidence for life on Mars. The White House called up NASA and said, hey, I heard you're sending this Opportunity rover to Mars. Do you want to send a second? And NASA said, sure, give me another rover. And so that's actually how we got the second Mars exploration rover on Mars. But yeah, it's a huge discovery, and it's really controversial. So everybody got really excited about it at the time, but now we're really not so sure about what those results mean, whether or not they mean that, there were microbes in that ancient rock that came from Mars.
Do you worry like Elon Musk is going to take a band of people to Mars and just ruin everything for everyone?
Somebody's going to.
And so that's why we need to study Mars now before it's been, contaminated by us.
It's true. Yeah, once you send people, people are just giant walking bags of microbes. Even the space station is constantly spewing out microbes into space. You can't seal a spacecraft to the point where you could actually keep Mars sterile once people are there. So yeah, once we send people, we're done.
Okay, so one question on my mind is it reasonable that there would be life on Mars? It's this other planet. Why is it that we should even think that life might exist there?
Right. So you're talking about why would life originate on Mars?
Yeah, like in what circumstances would it originate on Mars, and how does that inform where and how we look for it now?
So we think actually Mars, in its very early history, around a couple 100 million years after the solar system formed, may have been a lot more like Earth than it is today. We see evidence that there was liquid water flowing on the surface. So something was different about Mars that made liquid water stable at the surface. So now you have a possibility of having a much more habitable environment on Mars, not dissimilar to the environment the Earth was experiencing when life originated there.
That's really the key thing, because if you think about it, when these two planets, Earth and Mars, first started out, they were basically sort of hot, watery balls of planets, right? And so when they first started out, they both went through the same kind of evolution. They probably had, ancient magma oceans, and they were being bombarded by impacts, and they were, basically creating atmospheres that then allowed liquid water to be stable. And for the first, 500 million years or so of their evolution, they probably looked pretty similar. And what's really interesting about Mars is most of the surface of Mars that we see today was actually formed not too long after that. Most of the surface of Mars is like 3.5 to 4 billion years old. So what's really cool is that is the time period that we think life originated on Earth, somewhere in that time period. But on Earth, all of the rocks that could be preserved from that time that could tell us about how life originated, where it originated, all these things, they're all gone. They've all been destroyed by plate tectonics, by the constant recycling of the Earth's crust. On Mars, it's not the case. On Mars, a lot of those rocks are almost totally pristine. They're still there. They're still right where they were laid down. Ancient lake and ocean sediments potentially from 4 billion years ago could be sitting there waiting for us to find out about where life came from and where it originated.
Did Mars have a magnetic field at any point?
Yeah, so early on, again, it was really similar to Earth. It had, magnetic fields on planets come from the liquid outer part of the core, is this molten metal spewing around, which creates currents, which creates a magnetic field that helps protect us from radiation and all this stuff. So Mars, we actually see signs in these ancient rocks. They have magnetic field that's basically trapped inside of them, so that we know that when they cooled, when say lava cooled, it trapped a magnetic field inside of them, and we can see that today. So we know it used to. It does not today. which tells us that the core basically cooled down, it shut down, it's just a solid block of metal now.
That's it. So you could tell from the rocks, like, when that happened or how gradually it happened?
So you can look at the rocks and you can see when they formed, and if you know when they formed, you can say, like, okay, I know there was a field at this time. And so we think that happened pretty early. Like, we think it shut down around 4 billion years ago or even earlier.
I assume that would be a threat to life if there was life, if suddenly the magnetic field shut down.
Right. Not only are you now not protected from radiation from the solar wind, which is not great for life, we think what happened when the magnetic field went away is that the atmosphere was more susceptible to being sputtered away. So it was, bombarding life with radiation. It was slowly eroding the atmosphere, which is not great for life either because the surface will cool down. Liquid water will no longer be stable. So this had a huge effect on Mars and probably made it the desert planet it is today.
Yeah, that'd be interesting because if you could look in the rock, if you could find like microbe signatures at the same time as the existent magnetosphere, that would be compelling.
Right.
Yeah.
Right. It would also tell us something about how quickly life can originate. I think life originated really quickly on the Earth, but like Briony said, we don't have really much evidence of that because all those rocks are gone or really hard to find. So if we could find, 4.3 billion year old rocks on Mars that had clear evidence for life, then we know life can happen really quickly, which is a good thing if you're looking for life elsewhere in the universe.
So you have Mars. It's a little baby planet covered in water. It looks like the Earth. Everything's happy. And then it loses its magnetic field because it's too small? Is that why?
Yeah, it's smaller, so it cools down faster. So that liquid layer that creates your magnetic field solidifies faster.
So Mars lost its magnetic field because the inside of it cooled down, hardened. Ours hasn't yet. And then, because it's little and because it has no magnetic field, the atmosphere went away.
Right, because the magnetic field was basically preventing the solar wind from stripping the atmosphere away. There's actually a spacecraft at Mars right now, a NASA spacecraft called MAVEN, that's measuring the rate at which the solar wind is removing atmosphere from Mars. And so we actually know what that number is more or less now. And it's enough that that's a significant contribution. It really, over 4 billion years, it's a lot of atmosphere that got removed.
The atmosphere disappeared. The atmospheric pressure of the surface air dropped, and so liquid water couldn't exist anymore. Is that it?
Yeah, there's two things. The surface pressure dropped. There's a point at which water is no longer stable. You go straight from ice to vapor. But also, there was probably a greenhouse gas in Mars's atmosphere, like, say, CO2, which is the entire composition of Mars's atmosphere today, that helped with warming of the surface. So you start to get rid of that greenhouse gas. The pressure drops. Now you're losing that greenhouse warming and the temperature drops too. So it was those two effects happening at the same time, which were both bad for life.
So FYI, so the lower the pressure is, the lower the boiling temperature of water is going to be, right? And that's why if you go to like one of those high altitude cities, water boils at less than 100 degrees Celsius. It boils at a lower temperature, right? And so the idea is Mars is losing its atmosphere, so there's less atmospheric pressure down on the ground, and so water will have a lower and lower boiling temperature until it's either going to be vapor or ice. There isn't enough atmospheric pressure to maintain liquid water.
That's right.
It's basically, you can imagine if you put water on the surface of Mars today, it would just instantly boil away.
A watched pot never boils, except on Mars.
So how does this inform us about where we expect to find life on Mars? Because when we go and send the rover to go poke around, we're not just like picking up every rock we see, and we're not just sending the rovers to random locations, right?
Right. So this is actually a huge, huge debate we're having right now. So the rover that's on the surface right now is Mars Science Laboratory, also called the Curiosity rover. And so that rover actually isn't looking for life, kind of like we talked about. So it doesn't have the instrumentation to do that. Instead, what it's trying to do is understand what kind of ancient habitable environments existed on Mars. So for the past several years, Curiosity's been roving around in Gale Crater, which Curiosity has shown it was basically an ancient lake. It was this huge lake that occurred multiple times. It left behind all these river channels and deltas and lake sediments and all this stuff. And so Curiosity has been, analyzing the chemistry of those lake sediments, trying to understand what was the chemistry of the lake, what kind of microbes could have survived there. And so because of that, we have a pretty good idea of what these ancient environments looked like on Mars. But that's a totally different question from, okay, now I think I know that life could have survived on ancient Mars. Where would it have thrived the most? And where would the signs of it be left behind to go look for? And so the next NASA rover that's going is called the Mars 2020 rover. It's launching in 2020. And it's actually going to be looking for biosignatures for signs of ancient life on Mars. And so now we have to go through the process of trying to choose one place on Mars, probably our one shot to go look for signs of ancient life. And so the Mars 2020 rover has a whole different suite of instruments. It's going to look a lot like the Curiosity rover. It has the same chassis and the same kind of wheels and head and eyes and all that stuff. But it has a totally different set of instruments that are going to be much better at looking for organics, at doing kind of these microscopic analyses to look for signs of ancient life. We still have to figure out where to send it. And so this is actually a huge debate we're having right now. We have to figure it out in the next, 4 years, but it's really hard. We look at Earth. Almost every single environment on Earth is inhabited. There really is nowhere on Earth that is not inhabited by some kind of life. So how do you choose one place to go look, right? It's really hard. Do we go to an ancient lake on Mars? Do we go to an ancient hydrothermal field like Yellowstone, somewhere we have all kinds of minerals precipitating out and preserving life like that? Do you go to an ancient wetland site? Where do you go? It's a really hard question. So, if I asked you, okay, I want you to you have this one rover and you can send it anywhere on Earth to look for any kind of measurements you can take to understand the entire history of Earth, the entire history of life on Earth. What one place do you go to try to do that? It's almost impossible to really choose one place, but we have to.
And then it also has to be a safe place for this giant rover to land. So it has to be both scientifically interesting, but also won't give the engineers heart attacks that you want to land there. So you have to look at these things in tandem when you're trying to pick these landing sites.
Are those things in conflict? Like the more boring the landscape, the better for landing, but the worse for discovery?
Yep. Engineers would love to land in parking lots every single time if we could.
So what kind of instrumentation is it bringing?
So it's bringing basically lots of different kinds of microscopic investigations. So it's bringing things called Raman spectrometers that are really good at looking for organics and looking for the minerals that microbes could have left behind. It's bringing sort of a whole little the arm on the end of the rover. So the rover, it's this big SUV-sized rover, and it has this arm that comes out of the front that has all these instruments on it. And for reference, the size of the instruments on the arm is actually the same size as the first rover we ever sent to Mars, the Sojourner rover on Pathfinder. So it's huge. It's like trying to wield a lawnmower out in front of you and trying to place it, with micron scale accuracy to measure stuff. It's crazy. But so it has all kinds of microscopes and spectrometers and things to look at composition. And so, yeah, that's one of the key things we're looking for is organics. If we can find signs of ancient organics on Mars, and that's a great place to look for in more detail for signs of life.
Is it carrying microbe food?
No, so it's not trying to find existing life. We're not sending it anywhere that we might expect to find life. But the other really cool thing that it is going to do is it's going to collect a set of samples, really carefully selected samples, and then eventually another mission will go back and collect those samples and bring them back to Earth. So, once this rover finds all these places where, okay, we think there might be signs of life or this rock could contain signs of life, then eventually we can actually bring those back to our labs here on Earth to look at them in a lot more detail.
Is there a plan to bring back samples that way? Or?
Well, hopefully there's a plan. Now, is there money is a totally different question. So there's a plan. There's a couple different ideas for how we could do this. It's just, it's really hard to get that kind of funding that far in advance for NASA. NASA kind of runs on a year-to-year basis with money, so that's really rough. But it's a really hard thing to do to bring samples back from another planet, because not only do you have to send this, expensive giant rover in advance to select the samples, you have to send another mission with another rover on it to go get the samples, and that mission has to have a rocket that can launch either off a launching pad, or actually the new design I've seen is that the rover itself actually carries a rocket laid down on the back of it, and it's like a jetpack basically. So once the samples are all collected, the rover sticks the sample, like a ball of samples, on the top of the rocket. The rocket leans up and then launches off the back of the rover to go into orbit. And then you have this little ball of samples, floating around in orbit for potentially years and years. And eventually you have to rendezvous with it in orbit. You have to find this tiny ball, pick it up, and then bring it back to Earth and land on Earth. So it's a really complex, probably a couple of different missions we'd have to run to get it. But it's by far the best chance we have for ever finding, really convincing signs of life on ancient Mars.
I guess we can't steal the perchlorate from Mars as rocket fuel.
Probably not for a rover, but,
No, this has been proposed, right? Zuber had the case for Mars he wrote in the 90s, where you'd send a rocket, a one-way trip to Mars, and then you'd mine, the material you needed out of the Martian soil to send it back.
Kind of like in the movie The Martian, that's what they were doing. They were actually taking oxygen and hydrogen out of the atmosphere to create the rocket fuel. And so that's actually, when we send humans to Mars, that's probably what we'll do. There's a big study going on right now trying to understand, where would you get water for, not just for human survival, but also to use for rocket fuel and things on Mars. Would you mine ice? Would you mine minerals that have water trapped in their structures and try to extract it that way? That's a whole field of exploration right now.
Do like the people who are into astrobiology, are they on the, I can imagine there being a fight between people who want to preserve all of the biology and people who just want to explore like crazy. Is there a sort of argument over that?
I don't know. I feel like everybody who studies Mars kind of secretly wants to go there. And so I don't think any of them are really that hardcore against humans on Mars.
Yeah. You're talking a lot about biosignatures, evidence that life has existed. Is there any hope of finding, bacteria and stuff currently existing on Mars somewhere? And how would we look for it?
Oh, that's a great question. It's really hard, right? Because there just aren't that many places on Mars where liquid water is stable. And as far as we know, that's like the one thing you really need for life. There was a lot of talk last year about another discovery of water on Mars, but this one was special because it was not the discovery of ancient water. It was actually water on Mars today, liquid water flowing on Mars today. And it's all of these basically places near the equator that have these really steep slopes, like the cliffs of canyons and impact craters and things, where we've seen these really dark flows sort of flowing on seasonal kind of timescales down these slopes. And it turns out that when you look at those, you actually see salts inside those flows. And so we think those flows are actually liquid water that's coming either from the atmosphere or from, aquifers, water in the subsurface and emerging on the surface and flowing really slowly like a really salty sludge down these slopes. And so there's some people who think that those, we call these, the really scientific name for them, because we love acronyms, is RSLs, or recurring slope lineae, which is very exciting. But there's some people who think that these things could actually be habitable by life. Now, we don't know because, again, water isn't stable on Mars today. The only reason there could be water there is if these things are incredibly salty, like 100 times saltier than the ocean, like that kind of salty. And so we don't know if life could even live in that kind of environment. So we don't know, but that's definitely one place we would love to look. And NASA's been talking about making that a target for humans to investigate. But of course, that gets us back to, if we do that, then we'll totally contaminate them. So do we really want to do that, right?
So one of the things you mentioned was that you think that there might be liquid water under and possibly alive life below a certain depth under the surface of Mars, because down there liquid water can exist, and down there you're shielded from the radiation.
Right. Yeah. So if we think about the places that life could exist on Mars today, we talked about there could be these, liquid water flows on the surface. But if there's like an actual ecosystem that exists on Mars, it's in the subsurface, hundreds of meters down, kilometers down. We don't know, but that's totally possible. The problem is, how do you look for that? If it's kilometers down, you can't really send a drill. That's just not going to happen. And so one way we could look for that kind of life is to basically find, a fissure, a crack, somewhere like that has it's a conduit to the subsurface, and then have a rover or whatever, go up to this crack and actually sniff the air, sniff the atmosphere, and see if there are any gases or other weird things that don't belong there that could actually have been produced by microbes deep underground. And so that would be things like methane. So we actually, we detected methane on Mars, and we think it's possible it could be coming from these systems of microbes deep in the subsurface.
Yeah. The issue with searching for life elsewhere in the solar system is that we don't have a very good idea of what life unlike us looks like. So all of our tools are designed to look for life that is exactly like us, same exact biochemistry. So if we were to ever find life elsewhere in the solar system, how do we know it's just not us, contaminated in some way or shape or form? If we don't find anything with these tools that are targeted to look specifically for our sort of biochemistry, we might have just missed it because we didn't know what to look for. So this is my huge concern with looking for life in the solar system in general. It's a very, very difficult thing to do.
Yeah, I mean, if you start thinking about places outside of Mars, when you get out to the outer solar system, there are whole, we call them ocean worlds, right? There are all these icy satellites of Jupiter and Saturn and other planets that are basically water worlds. They have a thick layer of ice on their surface, but then below that we know that there are oceans, whole active oceans today. And these are the kind of places we would love to go explore and look for life inside of them. But, first it's really hard just to get out there. The oceans might be below, 100 kilometers of ice or something, so they're hard to get to. So it's going to be really difficult, but that's another place that NASA is really focusing on and looking for life outside of our Earth.
And what's exciting about these ocean worlds is that we might find evidence for a second genesis of life there. So unlike Mars and Earth, which have been throwing rocks at each other for billions of years, these icy worlds are protected by this thick layer of ice. So those rocks, even if they made it out there, which they probably didn't, almost certainly did not make it down to this ocean, tens of kilometers below the surface. So if we really want to understand a second genesis for life, another way that life may have originated, these are the oceans we want to target. But they're very, very hard to get to.
Yeah, that's the other thing that Mars has in its favor is that, it's a 6-month trip. We can get there. We can plan a mission and have, now and have it be there in a couple of years and it's done, right? So for these ocean worlds, it can take up to a decade to get out there and get in orbit and all of that. So it's really hard.
And we have no idea how to get through, 40 kilometers of ice
right.
to actually sample the liquid that's down there.
Okay, yeah. Okay. So, Zach, do you have any other questions?
I think that was it.
Yeah, that was fun. We talked about a lot of stuff. Well, thank you, Briony. Thank you, Catherine. You've pleased me. That was fantastic. Your efforts have borne fruit, and that fruit is sweet. Here's some fruit. Catherine, you get a radioactive banana.
Num, 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 num.
Good. And Briony, you get a pomegranate.
Yum, 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 crunch.
Okay, good. I'd like to thank our guest, Zach Weinersmith, webcomic king, host of the weekly Weinersmith that hasn't been
yearly Weinersmith.
Yeah, the yearly Weinersmith. Someday you'll come back and you'll conquer the world.
Someday when the children are out of the house.
Yeah, that's right.
Yeah.
So you can read Zach's webcomic at smbc-comics.com, the Saturday morning breakfast cereal. I'm sure you've all heard of it. Thank you, everybody.
Do I get a fruit?
All right, well, I'm going to say, we'll do this. All right, Zach, you get a Kiwano.
Yum. It's excellent guano.
All right. Hello, everybody. That was a pretty fun episode. Well, this wraps up Season 5. I can't believe that we've been doing this for pretty much 5 years. We're going to start back up in September for Season 6. I'm really looking forward to it. I have to start organizing all the new guests and experts and topics, and it should be a good time. Can you imagine that I organized the gravitational waves episode for this season the month preceding the big announcement of the detection for gravitational waves?
In the preceding July?
It's funny, one of our experts that was supposed to be on our January show about gravitational waves couldn't make it because he was busy writing the papers that were released in the February. Anyway, hopefully Season 6 should be as lucky as Season 5. Okay, so, announcement time. First off, please give us an iTunes review or tell other people who might appreciate our show about us. Online, maybe your families, maybe your friends. Maybe you got a nephew who's really into medical physics. Maybe you got a niece who's really into theoretical physics. Just tell people about us. It's pretty fun. The deal is nobody wants to go out and admit that they like physics, just like how nobody wanted to go out in public and admit that they like Pokemon until they filled the streets. Anyway, leave us an iTunes review and tell us which Pokemon team you're on, because this podcast, as far as I've taken a vote, is entirely Team Instinct. Well, show us wrong by voting for us. I don't know. Anyway, on another note, we're still humbly soliciting your donations. Our attempt to transcribe all of our episodes is going very well. So, your donations will go to pay for that big project. We pay our transcribers $50 a pop. Alternatively, they pay for server fees and also, the regular business of running a website. Okay, so you can sign up to donate monthly. Well, whenever we put out an episode, it's about monthly on our Patreon site. Or you can sign up to give us a one-time donation using PayPal through our website. Incidentally, this particular episode of the Titanium Physicists podcast has been sponsored by a collection of generous people. First, I'd like to thank the generosity of Mr. Gareth Edwards and Mr. Jeff McKenzie for their donations. I'd also like to thank Joe Piston, Ayesh Singh, David Johnson, and Megan Leon, as well as Doug B., Julia, Noah Robertson, Ian and Stu, Mr. Frank, Philip from Austria, Noisy Mime, Mr. Shlomo Dalal, Melissa Burke, Yassine Ouarzazi, Spider Rogue, Insanity Orbits, Robert Johnson, Madame Sandra Johnson, Mr. Jacob Wick, Mr. John Keys, Mr. Victor C., Ryan Kloss, Peter Clipsham, Mr. Robert Halpin, Elizabetha Teresa, and Paul Carr, Mr. Ryan Newell, Mr. Adam K., Thomas Shire, Mr. Jacob S., a gentleman named Brent Evans, a lady named Jill, a gentleman named Greg, thanks Steve, Mr. James Clausen, Mr. Devin North, a gentleman named Scott Ed Lowlington, Kelly Weinersmith, Jocelyn Reed, Mr. S. Hatcher, Mr. Rob Abrazado, and Mr. Robert Stietka. So that's it for Titanium Physicists this time. Remember that if you like listening to scientists talk about science in their own words, there are lots of other lovely shows on the Braculope Media Network. So check us out. If you go to iTunes and you click the name Braculope Media, they'll list all of our shows right there for you to listen to. Okay, so the intro to our show is by Ted Leo and the Pharmacists, and the end song is by John Vanderslice. Good day, my friends, and until next time, remember to keep science in your hearts.
Angela, don't be mad. There's something I gotta tell you, dear, before you come back here. I lost your bunny. I let him out of the cage. He was eating spring mix on the carpet, jumped through a window out into the haze, hopped down Magnolia Boulevard, no way he'll survive.
Is there a plan to send people to Mars at some point? I mean, I'm sure there's some sort of miasmic plan, but is there like an actual on-the-books plan?
Yeah, so it's actually, things have been changing a little bit at NASA. And of course, everything at NASA is subject to the whims of the president and Congress. And with a new administration coming in, next year, who knows, right? But as it stands right now, there's a big impetus at NASA. They've been calling it hashtag Journey to Mars, right? It's been everywhere. I mean, The Martian, NASA was all over advertising for The Martian because they were so excited about that. So there has been a lot more talk about it. And actually, it's been exciting for me too, because if you look at the history of NASA, they legally haven't been allowed to officially talk about going to Mars since about Apollo 10, because it turns out that, they actually had this plan to go to Mars back in starting in the 60s as, sort of a follow on from the Apollo missions going to the moon. But then Richard Nixon got into office and, prior to the moon landing said, guys, this is it. You're not getting more money after this. You have to cancel anything about Mars. There's just no way you're going to go that far. And so NASA, as of that point, was basically no longer allowed to really plan for that, other than, some fun research here and there and a few groups here and there working on it. But that's what's changed in the past year or two, is that there's a much kind of bigger picture effort to try to actually do that. Like, we actually had a meeting last year to try to get the scientists and engineers together to think about, okay, where would you send humans on Mars if you were going to go? Where are the places that might have these resources, like ice or water or metals or things you could mine from the ground that you could send humans there to explore and to use. And so that was huge too, because that was also kind of a first step toward trying to get humans there. So I guess I would say I'm cautiously optimistic, but I still think SpaceX is going to get there first.
And there are some technical issues too.
Yeah.
With going to Mars. It's a really long trip in a really exposed environment in space.
Yeah, so what's the plan for that? Do you get like lead or something? I mean, I guess it's hard to boost lead all the way to...
Lead long johns?
Yeah.
No, so as far as I know, we haven't figured that out yet. Actually, radiation is one of the biggest problems. There's been a lot of talk about, once you're on the surface, you can try to sort of build a habitat, and then on top of that habitat pile, meters and meters of like boulders to try to help protect you from radiation. But there's still the whole trip there and back, and that's, at least 6 months one way, if not more. And so that's a lot of radiation exposure. And in fact, the Curiosity rover has a radiation sensor on board, which is paid for by the human exploration side of NASA. And what they found is that the radiation is actually worse than we thought.
Oh, good.
Yeah.
Is it kill you quickly or kill you like you get cancer in 30 years?
It could be both. If you're lucky and there isn't a solar storm when you're on your 6-month journey to Mars, you might just get cancer and, die. If there's a solar storm, that might kill you due to radiation poisoning.
Right.
So.
Yeah. So even, SpaceX, Elon Musk said that they're going to have humans on Mars, really soon. They're going to be start landings on Mars. I think it was like 2020 or something. And then they're going to be sending missions every 2 years after that, with humans getting to Mars in the late 2020s, I think. But even, they have to deal with these same problems too. And they haven't been working on them for that long. So I'm really curious to see what, private industry decides to do with all this.
Again, maybe some people are just willing to take that risk, one-way trip to Mars.
A bunch of people signed up for Mars One.
Yeah. Yeah, but you can never send NASA astronauts that way, because NASA could never do that. So maybe SpaceX can.
Is it like the no one-way trips? Is that a NASA rule, or is that every space agency? Like, would the ESA send crazy people? But the Russians, they were cool opening up like Vostok. Maybe they'd be okay sending somebody.
The Russians actually tried to send a spacecraft to Mars that had life on it. Like, they purposefully tried to do this. It was a mission called Phobos Grunt. And it actually had an experiment on board that was funded by the Planetary Society, which is this US-based lobbying group. Totally recommend it. It's really awesome. They're one of the few citizen-powered lobbying groups that fights for more space exploration, which is really cool. But they actually funded, kind of crowdfunded this experiment that was basically a petri dish that was on board the spacecraft. The spacecraft was going to go to Phobos, the moon of Mars, grab a sample and come back. And the idea was to send this sample of life to Phobos and back and see what happened to it. But of course, if you crash that into Mars, you're like purposefully crashing life into Mars. And so that could be a problem. So, NASA has planetary protection, this bureaucracy that tries to prevent that, but they can't do anything about when Russia or China or Europe decides to send, dishes of microbes to other planets.
Because I was reading a little about this, and I know there's like an international space treaty that prohibits a nation from claiming anything in space, the rest of the universe. But I don't know what the rules are if you're like Elon Musk's crazy band of Mars explorers. Because I guess they're not a nation. I don't know, or at least if they are, they haven't signed the treaty.
That's a good question.
An analog is Antarctica. There's also an Antarctic treaty that prevents any one nation from owning parts of Antarctica and exploiting it for their own gains. So I imagine as a citizen, perhaps, of one of these countries, you can also go there and start mining, right? That would be frowned upon. So maybe the same rules apply, but I don't know all the details.
But how would you stop them? That's the question, right? They're basically becoming space pirates, and how do you stop space pirates?
Wasn't there a movie with Tom Hanks?
It'd be interesting to think about how it would affect things if private industry got there first.
Yeah, and it's totally possible. I mean,
or likely even.
Yeah,
I'd say.
Yeah.
NASA is too risk adverse. This is a very risky mission.
Yeah. Is that cultural, or is that like you worry about funding drying up if something terrible happens?
I'd say it's both. I mean, if you look at the public reaction to Columbia and Challenger space shuttles blowing up and killing all of their crews, I mean, there was a huge public reaction to that, and it was just.
I mean, they shut down the space shuttle program.
Yeah, and so NASA they literally can't afford to have any risks that are that high, and so that really limits how much they can do.
But it's weird because they were like horrible deaths on Apollo, but they seem to sort of move. I mean, that was back when NASA was like all crazy jet fighters, but like they seem to sort of move past it and do better. Of course, they had a lot more money, but I wondered, do you think there's been sort of a cultural shift when it comes to risk?
I think so. I think just the whole, idea of liability and that NASA is responsible for this, and I really think there is.
Yeah. But I assume there'd be a lot of astronauts who would be all for taking very dangerous missions.
Oh yeah. I don't think it's the astronauts that are the issue. I'm sure they would do it.
Yeah, and I think it's more like if you did have a mission that failed because everybody died, I mean, I think it's really unlikely that you would ever actually get to complete that mission, right? I mean, if you send a mission to Mars and everybody died, I find it hard to believe that Congress would be like, yes, here's more money to redo this and to actually make it work. So I think that's, in addition to kind of moral concerns about it, I think there's also a financial thing where, like, if you fail, you don't necessarily get another chance.
That's going to be tough, though, in the long run, because if you two are more excited, or not more excited, but like think SpaceX is going to be their first, does SpaceX have more ability to draw top talent compared to government institutions?
It's a different kind of talent, right? So SpaceX, they're not hiring very many scientists yet, right? They're mostly hiring engineers. And I think they might get to that point, But in terms of aerospace, I mean, NASA and the Jet Propulsion Laboratory, those are still huge places to go work as an engineer. I mean, they're really prestigious, right? So I don't know. It's a good question if there'll be a brain drain from NASA because of SpaceX.
Well, and I'm a huge fan and proponent of robotic spaceflight. You can do so much interesting science with robots that's way cheaper and less riskier than with humans. So I would take all of NASA's human space flight budget and just dump it all into robots. And can you imagine what we could learn about the solar system?
No, it's true. You could take, NASA's human exploration budget and dump that into just a bunch of simple rovers that you just bombed Mars with.
Right.
And I'm sure you would find something really cool. And that would be the way to really look for life. But because we're limited by funding and, what Congress wants us to do this year, that gets really hard.
Yeah, I remember there's an interview I remember watching with Carl Sagan towards the end of his life where I think he was complaining he didn't like the idea of the ISS. He was like, no, we should be sending robots everywhere instead of putting the space station 300 miles up. And the sense I get talking to space people is that's a lot of people agree with that, but maybe it's not what you're supposed to say. I don't know.
Yeah, I don't know. I mean, the space station they've done a little bit of science with it, but I think the big return from it has been almost entirely engineering. Like, how do you live in space? How do you design simple things that help you live in space? Like, how do you design a toilet that works in space? I mean, stuff like that. It's a lot harder than you think, it takes a long time to figure that out. So that's what the space station has given us, is that we have some idea of how to live in space other than, radiation and all those problems still.
Right. But it's like 100 times more, like it's 100 Mars rovers. I guess I don't know if they knew in advance how much the ISS would cost in the long run, but
I think it's blown its budget a couple times over.
Oh yeah, that's every mission NASA does, though. They always underestimate the cost, usually by like an order of magnitude sometimes.
Yeah. Do you think they feel pressure to do that though? Like to extract funds? You don't want to be like, no, actually, it's going to cost $100 billion. I tell you.
Well, it's a competition. So every mission that NASA runs is always a competition of some kind, either for the mission itself or for the instruments you're putting on it. And so, of course, in a competition, you're going to try to lowball it. Hopefully nobody is like outright, defrauding NASA, but they are going to try to be as cheap as possible, and that's not always realistic. So.
Although they force you to put reserves on these missions, like take the budget you think it's going to cost and then add 30%, and then maybe add another 30% because we don't believe your original estimate. So that's what happens with these budgets.
Should we talk about what the two of you are working on in particular, or is that outside of the show?
So I'm actually not a Mars scientist, so you might want to leave that out. Mars is one of the few planets in the solar system I've not written a paper about, although that might change here soon. My favorite place in the solar system, other than the Earth, which I mentioned earlier, is Titan, which is Saturn's largest moon. And Briony said that Mars is the most Earth-like planet in the solar system. Well, the Earth could be said to be the most Titan-like planet in the solar system, because Titan looks just like the Earth. It's got an atmosphere. It has liquids flowing on its surface. It has lakes and seas and sand dunes, but they're all made of the wrong materials. So Titan is an icy world. It's an icy satellite. So the rock there is made of ice. The liquids are not water. They're methane and ethane. So gasoline basically flowing over the surface. And the sand dunes are not made of the nice white quartz sand you find on the Earth on your local beach. Lake Erie, but organics. So we have these carcinogenic sand dunes on Titan. And I really love studying Titan and trying to understand how that world was formed and has been shaped through time.
And Titan is a moon of Jupiter?
Saturn.
Saturn, okay. So what's the view? If you're standing on Titan, do you see like a giant Saturn just looming above?
Well, it's going to be pretty hazy. So Titan has a huge atmosphere.
On a clear day, yeah.
Well, there's never a clear day on Titan. So it's going to be like standing in the LA basin on a really bad smoggy day and trying to see the moon. So yeah, you could probably just barely make out Saturn and just a sliver of the rings, right? Because Titan orbits Saturn in the ring plane, so you would just see the rings edge on.
Oh, that's interesting. So it sweeps out like an area of the ring?
No, so the rings orbit Saturn, and Titan orbits Saturn, and they're all in the same plane.
Oh, they're all in the same. Okay.
Yeah.
Huh.
So I think about Titan a lot, in addition to other places in the solar system other than Mars.
I know that they talked about one to Enceladus, but I don't know if there's one for Titan.
So the Cassini spacecraft has been orbiting Saturn since 2004 and will sadly perish next year, about a year from now. It's run out of fuel, and they're just going to send it right into Saturn. So that's going to be a very sad day. And I didn't think, honestly, that I would see Titan again in my lifetime. But recently, NASA announced an opportunity that would include mission opportunities to Titan. So now I have a sliver of hope that I might yet see Titan again.
Yeah, so I am a Mars scientist, but I also dabble on the moon and the Earth as well. And so I started out as a physicist, but I've been moving farther and farther away from physics to get farther into my career, and I'm becoming more of a geologist these days. And so I use satellites around Mars as well as the rovers on the surface. I'm actually on both the Mars Science Laboratory Curiosity rover team as well as the science team for the next rover that's going to Mars in 2020. And so I use those rovers to try to understand the geology of Mars and where we might go to look for those signs of ancient life. But the part of my job I really love that's actually not on Mars is going out into the field, out to places here on Earth to try to help us better understand Mars and the moon and other planets too. And that's a really important part of planetary science, is not just studying the planets, but also finding environments that are similar to the environments we think either are or used to be present on other planets to try to understand them better. So I get to go play around on glaciers and sand dunes and all kinds of awesome places here on Earth to try to help us understand Mars, which is really fun.
Yeah, it is a lot of fun. I'm with you there.
Yeah. But most of my job is, working with rovers and running rovers on the surface and trying not to crash them and all that.
Can you make one do a wheelie?
They do it all the time, actually, because that's, the way they turn often is like they do sort of a full 180 or something, and they leave little donuts behind them when they do it.
Why doesn't anybody, I guess there's nothing to watch the rover.
We actually can. We can actually see the rovers from orbit. From our cameras in orbit around Mars are so awesome. We can actually see the tracks of the rovers and the rovers themselves, which is really cool.
So can you make one go over a jump?
NASA would not be cool with that.
It's that risk aversion again. They don't.
Yeah. Oh man, if you think it's bad with humans, you should see how risk averse they are with the rovers.
You could go higher too, because it's Mars.
Yeah, you could probably jump over something. Yeah.
Has there been any attempt to land on the moons of Mars for exploration?
So the Russian mission Phobos, Grant mentioned earlier, was supposed to, and it didn't. But that's somewhere we're hoping to. And actually, one of the plans for how to get humans on Mars involves actually landing on Phobos first as kind of a first mission, just to get humans out there and learn how to get humans to Mars. So land on Phobos, spend some time on Phobos, maybe even land a rover on the surface that you could directly drive from Phobos and explore around on Mars with the rover. So NASA really is interested in it. And so there will probably be a mission to either image or land on Phobos sometime in the next few years, if I had to guess.
Wow, that'd be freaky though, because Phobos doesn't have much gravity.
No.
Is it enough that a human could jump off, or is it a little more than that?
It's probably about that. I bet you could.
Because
it's not very
scary.
big.
You jump too high, you die.
Hey, I'm sure you'd have to secure, if you had a habitat or something, I'm sure you'd have to drill into the surface to secure.
So how do you have a rover then? Do you have to have it just lock on all the time, or is it on a track, or?
Well, so if you landed something, you'd probably have to use a harpoon or something just to keep it safe. They tried to do that when they landed on the comet earlier last year and failed, unfortunately. But so the rover I was talking about would actually be on Mars, though. So you'd land humans on Phobos and then land another rover on Mars. And then the cool thing is, you could actually drive it with a joystick from Phobos, which would be really cool.
Oh, that's right. Because there's a 20-minute delay, I guess, right now.
Yeah, so the really cool thing about the Mars rovers is that they're almost like semi-autonomous. Like they do most of their driving by themselves, which is really, really hard. So like the way we plan these rover missions is we sit down, have this like 8-hour meeting and decide what the rover is going to do for the next day, send those directions to the rover, and then the rover, takes those directions and says, okay, I have to get from point A to point B, but then the rover has to figure out how it's going to get there. Like I see this rock, I have to go around this rock. And so they're pretty advanced.
Is that the newer ones, or have they all been that way?
So that's kind of the reason that they sent, even going back to Pathfinder in 1996, even that mission had a little bit of autonomy to it, because you can't drive these things like with a joystick. So that's the thing they've been developing for a long time.
Yeah, it's got to be a little scary. So you send the commands for a whole day's of work, and you just hope nothing goes wrong.
Pretty much, and it does sometimes. These rovers, they get stuck. They can get stuck in piles of sand. That's actually how the Spirit rover died. Was that it got stuck in a pile of sand. It couldn't get out, and then when winter came, its solar panels weren't turned toward the sun, so it basically just got cold and shut down and died. And it was really sad. What
I always think when I hear stuff like this, my wife is a scientist, and I always imagine there's some graduate student who is banking all of her research on what the rover was about to do, and then it got stuck.
I knew those graduate students.
Really?
In my office, yep.
What do you do? Do you just, I guess, you just do something else, or
just work? There's so much data from these missions.
Right.
Yeah.
Something.
You should never plan a PhD based on data that doesn't exist.
Exactly.
I had some colleagues who were basing their thesis on a Phoenix lander, which landed in 2008, and we were all, white-knuckled, making sure this thing didn't create a new impact crater on Mars. So, it didn't. Spoiler alert. It worked.
Hey, Briony, the first rover, they said it was like a little RV rover, the Sojourner. Yeah. Was that it?
Yeah, Sojourner is kind of shoebox sized.
And then it had a big mother station, the Pathfinder.
Right.
Right. So I'd heard that the Sojourner, the little rover, was solar powered, but the Pathfinder used some kind of fuel. And so the Sojourner wasn't actually going to run out of energy, but the Pathfinder was. So that's
totally
the end of the mission.
No,
and then I'd heard that the last instructions they gave the Sojourner were to circle the Pathfinder and wait for further instructions. And then the mom died. And so the Sojourner's still just circling its mom, waiting for us to talk to it.
No, I've totally heard the exact same thing, and it makes me so sad every single time because it's like a lost puppy, circling on Mars, and it can't find its mom, and
so it's true.
I think it's true. I don't, I'm sure, if that happened, I'm sure the rover would have hit some fault or something, and it would, it was like a software fault would have stopped.
Or it could have gone mad by now.
Robot overlord of Mars. It's true, though. Mars is actually the only planet we know of that's entirely populated by robots.
Are there any other planets where there's some little lander we put down, or?
Well, there's Titan. It had a lander that died after a few hours. There's Venus.
That's right. We have a photo, right?
Yeah. There's Venus, whose spacecraft melted, presumably, after a few hours. So there's puddles of spacecraft left behind.
It's got the only melted robot.
But Mars is the only one where they're all alive, and there's alive, running around on the surface.
Could we hear, since we're probably close to out of time, what would be your ideal, if you had $10 billion to spend on a Mars mission, what would it be like?
Can I send myself to Mars? Does that count?
Yeah, totally.
Yeah, I don't know. It's really hard to pass up human missions because at the end of the day, robots can do a lot, and I think, robot exploration is really important. But at the end of the day, a human on the surface, especially like a geologist or a astrobiologist, could do so much more than a robot could. Again, robots move at 0.025 miles per hour. The area that the Opportunity rover has taken 10 years to explore, you could have explored in a couple of days with a human. So I think you really can't pass up humans. So if you gave me infinite money, I'd just plan the best, most badass human astronaut exploration of Mars.